Hi, welcome to this presentation, which is part of the open courseware entitled Vapor Concepts and Validation. The topic of this presentation is Common Practices in Validation of Remote Sensing Data Products. My name is Solomon Siu. I'm a senior lecturer at IHE Delft Institute for Water Education. This video lecture aims to enable you to define what validation of remote sensing data products mean and to describe why remote sensing products involve uncertainty and the challenges of validating remote sensing data products. Satellite remote sensing provides a practical way to map land surface parameters at a global scale and at a regular time. Advances in remote sensing technologies and retrieval algorithms enables us to derive many biogeophysical parameters to enhance our understanding of the Earth's surface interaction with its atmosphere. Remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation from a distance. Remote sensing data have been used for various purposes, including biodiversity and ecosystem sustainability, food security and sustainable agriculture, and water resources management. Although remote sensing provides a practical way to map land surface parameters, most of the parameters cannot be directly observed, but are indirectly calculated from satellite observations through retrieval algorithms. There are 6 stages to produce remote sensing data. There should be a source of energy, which can be the solar energy or energy emitted by the target object and sensors. This energy, or the electromagnetic radiation, is transmitted to the target object. Then, the electromagnetic radiation interacts with the target object and is transmitted to the sensor for the image to be recorded by the sensor. After this, the image passes through retrieval algorithms to produce the data. Due to the complex nature of the physical process of electromagnetic propagation and their parameterization in the retrieval algorithms, remote sensing data involve uncertainty which biases their application. The uncertainty associated with remote sensing data is a result of a combination of factors related to the limitation of the instruments, the spatial and temporal variability of the variables, the complex nature of the data processing algorithm, and human factors in interpretation of the data. Therefore, discrepancies exist between satellite-derived products and the real status of the variable they intended to measure or estimate. Not only discrepancies exist between satellite-derived products and the real status of the variables, discrepancies also exist between different satellite products for the same parameter or the same product over different regions. While efforts are made to minimize the uncertainties associated with remote sensing products, they cannot be entirely eliminated. Therefore, in order to improve the application of satellite-derived products, it's crucial to investigate the accuracy of satellite products. This process of investigating the accuracy or error determination process is referred to as validation. The term validation has been defined in several ways in literature. For example, Justice and co-authors defined validation as the process of evaluating by independent means the accuracy of the satellite-derived land products and quantifying their uncertainties by analytical comparison with reference data. Rogers defined the purpose of validation as the confirmation that the theoretical characterization and error analysis actually represent the properties of the real data. Validation is also understood to be a verification against requirements which ensure that the data are adequate for an intended use. Validation of remote sensing products is challenging due to several factors, including the large spatial scale mismatch between in situ-based measurements and remote sensing pixels, the variability or heterogeneity of the land surfaces, and the absence of complete, continuous, and consistent in situ dataset. The general validation process of remote sensing data includes the steps of collecting the data, both remote sensing and reference data, a quality assessment of the data, spatio-temporal collocation or spatio-temporal arrangement, comparison metric calculation, and analysis and interpretation of the metric results. To begin the validation process, both the satellite data and the reference data should be collected and pre-processed. The choice and collection of the reference data is based on several factors, which are sometimes based on a pragmatic decision. In selecting the data, the following questions are considered. Do the data provide meaningful estimates of the investigated geophysical quantity? Are the data expected to be accurate enough to be able to draw desired conclusion from the validation process? And are the data publicly available and accessible? After the data has been chosen and collected, quality assessment is needed. This can include collecting data quality information from data providers, checking the physical plausibility or credibility of the collected data, visual inspection of the data, or tests for temporal consistency. The remote sensing data and the reference data should be close to each other relative to the spatio-temporal scale, and the differences in spatio-temporal resolution should be minimized. The amount of the data to compare should also take into account that robust statistical analysis can be made. Statistics computed from short duration of data are less reliable than those computed from long duration of data. The choice of metrics used within the validation process depends on the application and data availability. The most commonly used pairwise methods are the correlation coefficient, the bias, and the root mean squared deviation. There are, of course, many more comparison metrics used in validation of remote sensing data. After the comparison metrics have been computed, the results need to be judged if they are compatible with the requirements and if the dataset is suitable for the intended application. Once you have selected and validated a product, there are three options. 1. Use the product, assuming the product is accurate and has the appropriate temporal and spatial resolution to fit your requirement. 2. Use the product with some correction, for example, bias correction. Or do not use the product if the product is inaccurate or doesn't reflect the conditions on the ground in your area of focus. These are some of the references I used to prepare the presentation, and for you to read more about remote sensing data product validation. This is the end of this presentation. Please check out other videos and resources on the OpenCourseware to learn more about vapor concepts and validation. Thank you for your attention.